Question number 9. Lakshmi combined 0.0500 moles of aqueous lead 2 nitrate with the same quantity of aqueous copper sulfate and observed the reaction below. This is the reaction. By filtering the products, 14.8 grams of lead 2 sulfate powder was recovered. What was the percent yield of lead 2 sulfate? Okay, this is the answer, the final answer that we're looking for. What we're going to do is we're going to start with 2 separate bases and calculate the maximum amount of lead that we could recover. This is by far the most complicated question that we've done so far, but it won't take very long. We're starting with moles, 0.0500, and let's look at lead sulfate, or pardon me, lead nitrate, PbNO3, 2. We don't have to look up the mass of that because we're starting with moles. The mole ratio of our lead sulfate, which is our product we're after, is 1:1. So 1 mole of PbSO4 for every 1 mole of PbNO3, 2 is our mole ratio. The only thing that we have to look up is our mass of lead sulfate. So we go to our periodic table again. We find that Pb, when we look at our periodic table right here, Pb has a mass of 207.2. Sulfur has a mass of 32.066, and our 4 oxygens have a mass of 63.996. We add these together, we end up with a total of 303.262 grams of PbSO4 for every mole of PbSO4. Our units, moles cancel with moles, moles here cancel with moles here, and we end up with grams. We go on and do the math. 0.05 times 303.262. I left out the 1:1. We end up with 15.163 grams of PbSO4. Now normally, in order to calculate the maximum yield, I would have to also calculate how much copper sulfate, based on how much copper sulfate we have, how much lead sulfate could we make. But notice that the ratio of these 2 reactants is exactly the same. It's 1:1. So if we start with the same moles of each one of these reactants, we're going to end up making the same amount. So there is no limiting reagent or anything that could be considered excess in this calculation. It greatly simplifies our calculation because we only have to do it once. The question said that they recovered 14.8, so what was the percent yield? Well, percent yield is actual over theoretical. That's the fraction. We multiply by 100% to get percent yield. So we can go 14.8 divided by 15.16. 14.8 divided by 15.16, multiply by 100, and I get 97.62%. Now, It says be sure to use the correct place value. Notice that we had 3 significant figures here, 3 here, 3 here. So really I should have 3 here. So I'm going to strike off this last 2, and I'm going to record on my answer document 97.6. We don't need to record the percent. Question number 10. In a closed chamber, 58 grams of propane gas and 220 grams of oxygen gas are sparked to initiate this combustion reaction below. What is the limiting reagent in this reaction? So this is a case where we're going to have to see which one of these makes the most product, or which one of these runs out first. 58 grams of propane, that's C3H8. If we multiply 12 times 3 and add 8, we find that the molar mass of propane is 44 grams of C3H8 for every mole of C3H8. Now what we can do, rather than do this equation twice, is I can figure out how much oxygen I would actually need given this amount of propane. So let's look at the mole ratio of oxygen. 5 moles of oxygen for every 1 mole of C3H8. So my grams of C3H8 cancel and my moles of C3H8 cancel. I'm left with moles of oxygen. Oxygen, O2, is approximately 32 grams of O2 for every mole of O2. Now moles of O2 cancel with moles of O2, and I can do this math, and I can say, given 58 grams of propane, how many grams of oxygen will I need in this calculation? I multiply 50, or I take 58 as my basis. I divide by 44 grams. I multiply by the mole ratio of oxygen, and then I multiply by the molar mass of oxygen. What I end up with is 210.9 grams of oxygen. So by combusting 58 grams of propane, I am required to have this many grams of oxygen. If I look at my given, I see that I have 220 grams, but I only need 210. So I have more than enough of the oxygen, so this must be the excess. If oxygen is excess, then propane must be my limiting reagent. Now, remember that limiting reagent is one of the reactants. These two, water and carbon dioxide, are products. So we already reduced our answer to just these 2 reactants.